Welcome back to UVA Data Points. I'm your host, Monica Manny. For our fourth and final episode of Season 1, we're featuring a conversation in the area of analytics. As a recap, here's Professor Don Brown with a description of analytics.
So analytics, the really easy way to think about it is analytics is the part of our model that turns the data into useful information. For instance, in health, people have been using tissues since Leeuwenhoek, I guess, since the inventor of the microscope. But, we've been thinking about looking at samples of the body and trying to understand what's going on. In pathology, you take tissue samples and you try and understand what that tissue is telling you about possible disease states. It's very difficult to interpret, and pathologists spend a lot of time in school understanding how to look at those images and interpret them in ways that are meaningful to understanding disease states. Well, we're finding that we can take and build machine learning analytics that can really do as well or better in some cases, because it's not something that humans come about naturally. Looking at that kind of data, we're accustomed to looking at, frankly, the savanna, trees, bushes, antelopes, lions, things like that. We're not accustomed to looking at cells and cell lines and trying to understand how these things are normal or different or what's happening in them. So by applying analytics to that problem, we can really start to understand characteristics that are meaningful to predicting disease states or to estimating disease states and predicting trajectories of those disease states. Frankly, when people think about data science, they typically think only about analytics. And there's a reason for it, because analytics is really what turns the data, as I say, into something that people can use in order to get to make decisions and to understand what's happening in the world.
For our exploration of analytics, we're diving into the world of sports. But just so we're clear up front, this isn't simply a discussion of Moneyball. As you'll hear in the conversations, Moneyball was only the very tip of the iceberg. Because of the advances in machine learning, wearable technology, and computer vision, the field of sports analytics is a new game. Today's conversation gets into the details of these advances, as well as the ethics surrounding the implementation of this technology. To discuss all this, we've brought in two experts from the UVA School of Data Science, Natalie Kupperman and Stephen Baek. Natalie conducts research within the domain of sports medicine, and Stephen's research has a focus on geometric data and computer vision. And so their combined knowledge leads to a wide-ranging conversation in the cutting edge of sports analytics. Given the complexities and nuances of the topic, we asked Professor Don Brown, who you just heard from, to moderate the discussion. Don is a heavy hitter here at UVA. In addition to his expertise in engineering, data science, medicine, and business, Don is also a key reason the UVA School of Data Science exists. He was instrumental in the formation of the Data Science Institute, which eventually became the School of Data Science. Don also has a wealth of knowledge within the area of analytics, so he leads a wonderful discussion between Stephen and Natalie. So with that, here's episode 4 of UVA Data Points.
All right. Well, hello. I'm Don Brown. I'm the Senior Associate Dean for Research in the School of Data Science. I'm also the co-director of the Institute for Translational Health in Virginia. And and a faculty member in the School of Data Science and in the School of Engineering. And I'll kick it over to Natalie.
My name is Natalie Kupperman. I'm an assistant professor in the School of Data Science.
All right. My name is Steve Baek. I'm an associate professor of data science here at UVA.
Okay, and I guess to kick things off, we'll just go around and talk a little bit about research that we've been doing that's related to sports and sports analytics. For me, it's been fairly recent. I've done a lot of work in the past in areas including time series analysis, and recently I've been looking at a lot of data that's coming out of time series from sports, particularly around exercise testing and things like that, using these methods in deep learning. How about you, Natalie?
So my research started on the sports medicine side. I'm trained as an athletic trainer. That's most of my education. That pivoted a little bit when I learned about the sensors that sports teams were using and how we could use those sensors to start to understand injury risk on the field. So then when I was working on my PhD, I was specifically working on how do we take all of that sensor data and other data that we collect on the medical side and try to put it together to reduce injury risk. And so I'm continuing that on and also broadening my scope a bit in the sports analytics realm.
Oh, that's great. Thanks. And Steve?
So my research is about shapes. I'm interested in analyzing geometric data. And then to my perspective, human body is such an interesting geometric objects. So my PhD research actually started, with this concept of modeling human body shapes in a data-driven way so that, we can have like a computational model of people, and then we do, analyze a variety of different aspects of people using those computer models. So that's kind of how all this gets started. And then sports analytics, I think, is kind of a general connection to my original research because, it is related to, human body and how they move and, things like that. So I use the tools of computer vision, computational geometry, and machine learning to understand and analyze, how people move from the perspective of, their geometrical change of posture and the body shape, those kind of things.
That's great. When people think about sports analytics, they naturally gravitate to Moneyball and those ideas. And I think it's natural because that obviously was a cool book and a cool movie and all that kind of stuff. But in listening to you, it seems like you're both doing things that are quite different from that, as am I. So maybe, Natalie, can you talk a little bit about the evolution of sports analytics as you've seen it and how you're involved in different aspects of it?
Yeah. I like to tell people that we've been interested in athletes since the Greeks in the Olympics. The Greeks studied their athletes to make them better performers. And then in recent years, in modern times, since the 70s, 80s, we've started to collect more data on our athletes. Stats have gotten better. Stats started to become more publicly available, which is where Moneyball came from. Moneyball was looking through just tomes and tomes of stats and amalgamating that data and creating models. Since then, we've gotten even more technology, including sensor technology. We store our data better from the medical side to the stats side. We have next-gen stats. So where I think things are really going now is not just how do we make the stats better and the game outcomes better. We're now looking at individual athletes and how do we make them healthier and better performers on the field, whether they're in high school, college, or professional level. And that's where some of the exercise testing comes in. That's where the sports medicine comes in. There's more cameras on fields and on pitches, which is where Steve's research is really coming into play on a large scale. So some of the problems now are, how do we pull this data together? Some of it is, how do we do this at scale? And then also, I think, how do we think about an individual athlete, and also how do we think about a whole team, and not just the outcome of the game or who's the best player out there. It's really looking at these dynamical systems of sports.
Yeah, that's great. And Steve, what do you think about the evolution of sports analytics?
So I think Natalie summarized things pretty well. So I can only talk about from the perspective of computer vision. Computer vision has been around for a while in sports industry. They've been used to, produce all this cool like replays and analysis result in the TV broadcast and things like that. But recently, there's been a huge progress with all this deep learning and artificial intelligence stuff, where computers now have this cognitive capacity to, to tell, where people's major body joints are located at each different video frames, and then from there we can generate, a huge quantity of motion data of the players during the game, during practice. All of this creates this very exciting opportunity as of today, where you can collect all this data and then distill some interesting knowledge about how athletes perform and get injured and things like that. So that's kind of all this where all this exciting new trend is going towards, so to speak.
Yeah. And I think that's really where like mine and Steve's fields are colliding, is on the fact that from video analysis not using markers. So there's not markers. And I think people who might be listening who are more know about things like Vicon, where we use markers to look at motion analysis, how time intensive that is, and how you only get maybe 10 steps if you want to watch someone run of their motion. Where now we can get an entire game, and the fact that we are to the point where they can get major joint angles is going to revolutionize how we look at injury in these sporting contexts. I don't think I can emphasize that enough to people, that's a huge deal in our world.
Can you say a little bit more about this? I mean, how is it possible to get these joint angles, particularly in a game that has 22 players on a field, just to pick one game?
Right. The traditional motion capture systems, because computers were, back in the days, were not that smart to be able to understand where in the image or video, people's body joints are located. People had to place markers, visual markers on the physically on the body of the of the athletes, and then those markers are. Those markers basically provide a visual cue for the computer systems to analyze and guess where the body joints are located, and then how the bones move, as the athletes, perform certain things. But those markers are, if you think about it, quite burdensome because each time you want to scan the movement, you have to physically place the markers on the body of the subject, and then that takes a lot of time because you have to place the markers in a very meticulous way, and then there are like hundreds of markers that has to be attached to the subject, which is super time-consuming and tedious. But nowadays, with the advances of data science in general, what computers now able to do is to analyze all the pixels in the videos and images, and then make a very good estimate of where those body joints are located. And then the fact that you are able to tell the body joints without any markers means that you can reconstruct the 3D body configuration of the people from videos and images. That means, you don't really need any expensive motion capture system. You don't need to spend your time on placing markers and, things like that. But you can use some, plain, video cameras, like your smartphone even, cameras, and then you can collect the motion. You can record the videos of people doing various things, and then eventually run this, machine learning algorithms to tell where the body joints are located. And then, from there you can, compute the 3D joint angles, the joint velocities, and, things like that, which all can become really useful information for people like Natalie to understand and analyze people's movement.
Yeah. And also be able to capture that with multiple people. Often when we use the markered systems, we have to be in a lab environment that doesn't go onto a field or a pitch. So not only do we get the individual, we also get the individual in the context of the team and the opponent. Which then gets into a little bit more of the competition uses for computer vision in sport.
Let's talk a little bit more about that. In order to capture, again, for a large game with a lot of players on it, you're going to need multiple cameras at multiple angles. Do you do integration of those data in order to make sure you've got the right player at the right spot across those cameras? Or how do you put that together? How do you get one picture? Because obviously, depending on where the camera is, the player's going to be blocked. They're only going to be seen by certain other cameras, and you're going to have to look for those correct angles. And it seems like it'd be a tedious thing. Obviously, the computer, the algorithms that we've built will allow us to go through that very rapidly, but still, it's an issue in how to integrate those different perspectives from the different cameras. So can you talk a little about how that's done?
Yeah, that's a great question, Don. There are various different recipes, so to speak, in terms of how we, set up the cameras, and then how to, point those cameras. I think the typical setup is there are multitude of cameras installed in a stadium from various different angles. I think people prefer to be more, abundant as opposed to, like finding the optimal number of cameras, which is, because of the reason that you just talk about, like in a lot of team sports, specifically, there are a lot of collisions, physical contacts, and things like that. And then from computer vision perspective, that's kind of a nightmare because, there's a player on an image, and then on top of the player, there's another player, obstructing the view, and for example, football is kind of like the most challenging problem, I would argue, and then that's because all the players during the play, kind of in a very close physical contact, and then that poses a lot of challenges in terms of finding the right view of where the important event has happened. So right now, I think the current paradigm is to just place as many cameras as possible. And then, using the technology called camera calibration, which is the process of finding the parameters of how the cameras are set up. So basically, where the cameras are oriented, where the cameras are located in the 3D space, what are their focal length, and those kind of things can be pre-computed. And then once you have the pre-computed set of camera parameters, what you can do is to run what is called a pose estimation algorithm, which is essentially a machine learning algorithm to find the major body joint locations in the videos. And then those two-dimensional informations then gets reconstructed by using the camera calibration matrices. And then eventually you can reconstruct the 3D view of the players on the field or in the practice areas, and things like that.
Yeah. So it seems to me, as you say, football is the most got to be one of the most challenging ones, and I'm imagining, for instance, baseball and cricket would be among the least challenging. But correct me if I'm wrong on this, and maybe hockey and basketball in between, because of the speed of motion of their. There's a lot of contact in those, and they're very, very fast. Talk a little bit about the kinds of sports that this has been used for, and the ones that you think are particularly successful, and the ones for which we've got some work to do.
So from the things that I know, I think baseball was the sports where all this, computer vision application has started. So baseball obviously is a sport that has, I think, the one of the least amount of contacts between players. And then, if you think about it, like all the players are sort of, distributed on the field, and then they're kind of far apart from each other. So from computer vision perspective, it's much easier problem compared to, high contact sports like football. So I think about like a decade ago, there were people who are developing an app basically where you can point a camera towards a pitcher, and then the algorithm behind the camera basically analyze all the body movement of the pitcher so that they can calculate the release velocity of the ball, and how their joints are, how their joints move when they throw the ball, and so on and so forth. But now with the events of computer vision technology, I think we are gradually tackle and go into more complicated problems like football. And then one of the things that enables this kind of, one of the things that it allows us to solve this kind of, highly challenging situation is because of the fact that now machine learning algorithms can do so much more complicated things than just recognizing pixels. It can actually make a pretty reasonable guess in case there's an occlusion, for example. So when the player posture is hidden because of some occlusion, nowadays, what machine learning algorithms can do is to make a reasonable guess from the information that's available. Things like what happened before and after the current frame. You can you can sort of interpolate their body movement from those adjacent frames, or in case there are multiple camera views, you can combine all this information to sort of reconstruct and make a reasonable guess in terms of what happened in that occluded scene, that sort of things.
Yeah,
I
right.
think it's important to note, too, that a lot of the computer vision first came up for competition and rules' sake. We saw Hawkeye being used in tennis, first at the U.S. Open, to corroborate the line judging. And that was really revolutionary in the sport of tennis. We've seen some of it in baseball, too, with the rules, with umping calls. And now we're going to see it in the World Cup with FIFA. They are instituting computer vision to do their offsides call. And what I think is really interesting there is that as of now, and this could change once all the players arrive for the World Cup, is that the ball itself is going to be censored for those offsides calls. And so I think that it's important to know that this stuff came a lot from competition and all the debates we have around line calls and safe or out or offsides in soccer or in hockey. That's a big deal too, offsides. And a tough one to make when the game is moving so quickly. And because all of those cameras were put into stadiums, then scientists like Steve were able to go in and say, hey, we can even do better. And we can actually look at these athletes in a very microscopic way at their joint angles. And so I think this, depending on kind of where your interest in sports is, there's a lot going on both sides, competition and on health. I'm really looking forward. I'm not the world's biggest soccer or football fan. I guess if we're calling the World Cup, we should probably call it football, appease everyone else in the world besides Americans on that term. Then I think it's going to be really interesting to see how the fans react to having offsides called at like a millimeter. And does that really go to the spirit of the game? So I think those conversations are so interesting, from how the game is played to just the water cooler talk the next day after the game is really interesting. That being said, because all those cameras will be installed in all the World Cup stadiums that they're playing at in December, all of their joint angles and all of that possible injury information or health information will also be available to at least FIFA, maybe researchers eventually.
Well, let's explore that for just a second.
Yeah.
It's not just joint and health information from the standpoint of injury prevention and things like that, but you can actually make inferences about the performance of the athlete, can't you? Based upon all those the information you're getting from the. So talk to me a little bit about I'll say the privacy and ethical issues for the athlete, because now you can actually judge performance. You can say something about how the athlete has done in various situations, can't you, with this technology?
Yeah. I think it's easiest to speak about this at the professional level, mostly because all of the data is brokered in their collective bargaining agreements. So at the professional level, their data is very secure. So if we're using the MLS, if we'll stay on the soccer example, the MLS might be collecting data, but if the MLS is collecting it, then only the MLS has access to it. The data that the teams collect, the teams have access to. And then I know in the NFL, they're collecting and they're doing a lot of work with injuries. And not even the NFL has access to that data. Only their research teams can look at the data from the injury levels. So there's a lot of levels of protection, and I'm just grazing the surface on all these technical nuances of these contracts. But I will say I do feel like most professional sports in the U.S. have done a good job or the collective bargaining agreements, I should say, have done a good job on brokering how that data is secured. I think as we move down levels where there isn't that interface between the people who are paying for the technology and collecting the technology and the people that data is being collected on, where there's not an interface there to have collective bargaining agreements, that's going to vary from institution to institution on how that data is collected and secured and possibly used, which we could probably do a whole podcast on in general. And I'm sure Steve has some to add to that too.
Yeah, adding on to the data security issue, another thing I want to mention is AI sort of being used in the decision-making process. I'm pretty sure you watched a movie called Minority Report. The spoiler alert, what that movie describes is a future where there's an artificial intelligence which can predict the crime so that, even before the crime is committed, the AI can tell who's going to commit a crime, when and where, so that, what the movie is telling us is this kind of a dystopian future of, people get arrested even before committing a crime. So I don't know if this analogy is appropriate, but I'm sort of, also concerned about this possibility of AI being used in a decision-making process that is not, totally fair to the players, if you will. So what I'm trying to say here is, like AI algorithms are never perfect. They are not 100% accurate, but people tend to have this biased perception on data science and all this AI technology where data says X, and then that must be true. That's sort of a bias. And then I think one thing that the data science community will need to talk about is how this, for example, injury prediction data gets used in the decision-making process, or the performance prediction data gets used in the decision-making process, given that those prediction algorithms are not 100% accurate, right? Mm-hmm. So I think that kind of poses a very interesting ethical dilemma that I think all this data science community has to tackle.
And on the prediction side, I know when I talk to people about injury prediction, because if I go in and talk to coaches and I'm like, if we could solve any problem for you, what's the problem you want to solve? They're like, we want to predict injury. And I get that. I would love to also be able to know that next day an athlete's going to be injured so we can somehow help them to not get injured. However, that's not possible. We can't predict all injury in sport. And so I always try to temper my words, and that's why I try to use words more like injury risk mitigation. So what if we think that someone is trending towards a possible injury? What are steps we can take beforehand to either change their workload, change their equipment, something like that doesn't inhibit their performance or their chances of being on the field, but can help keep them healthier for whatever injury we think they're headed towards.
And you guys have raised two very interesting points at least, and I want to come back to the prediction, particularly of the I'll say the strategy and tactics in a sport. But let's follow up, Natalie, with this idea of the injury prediction. It seems to me that what you need for injury prediction is not just what's on the field. You need all the stuff before the game. In other words, and I know that, and we haven't talked, we talked a lot about cameras, but basically the athletes are censored up. And you're talking about the censoring on the ball. The puck is, everything is getting censored, and they're really censored up in the sense that you're measuring what, heart rate?
Heart rate's actually quite challenging. We get a lot of drop.
So what are we measuring on the?
So they a lot of sports will wear a sensor either on their back in between their shoulder blades, or there's ones that also fit kind of in the waistband of their athletic shorts or pants. And those sensors have a 3D accelerometer, gyroscope, and magnetometer. So we're getting directional movement, we're getting impact motion, we're getting accelerations, decelerations. If they're playing outside, those sensors also pick up GPS. Yes. So it's using the satellites in the sky, and it's being captured at a lower rate, and so the accuracy isn't the best, but it does give us a fairly good picture of at least how many miles did they run, how many times did they accelerate, and at what intensity did they accelerate or decelerate. Deceleration tends to be more of a concern when we think about injury. So we have all of that. I do think one of our next, and probably people are working on this now and we'll probably work on it here at Virginia at some point, is understanding how the camera data and the sensor data interact with each other and how those are similar or how they are different. Because the camera systems are very expensive and our athletes typically don't practice and compete in the same places, but their sensors are always with them. So if the camera data is giving us this really amazing information to work with, how can we, amalgamate that with the sensor data so that our sensor data becomes even better? Because the sensor data can be extremely noisy. However, it's leaps and bounds over guesstimating how many miles they ran in practice. So that's one of them. Some teams do use heart rate. It's just very noisy and there's a lot of dropout. So the teams I work with, I tend to stay away from looking at heart rate too much. And I have not found a lot of uses for it. Most athletes that we study are very healthy and their heart rates don't really give us that much to go off of, frankly.
Yeah, I guess that the data integration, I think, is, that's been an area of research for me for a long time across a bunch of domains. That clearly seems to me to be another dimension of where we can go, because it's not just video, it's all the other sensors that are available. But I guess I want to go back to the question I was asking you earlier about the injuries. It seems to me that to predict an injury, don't you need to monitor them before they're playing the game? In other words, during the period of time that they're not, when they're working out. I mean, I know, in fact, ironically, I was speaking to a former Penn Stater who went on to play in the NFL. He has 2 Super Bowl rings, and I just happened to talk to him this weekend. And he was talking to me about a number of these issues. But he was saying that, frankly, at Penn State, and I don't know if he said that they have, without a doubt, in his mind, the toughest workout. That the workout is way tougher than the game, and that they played all these. Said Joe Paterno was fanatic about getting people to really hit hard during workouts, and so and training sessions. So I'm wondering, monitoring those workouts and training sessions, it seems to me is at least as important for injury prevention as the game itself.
100%. And we know from epidemiology research that more injuries happen in practice for multiple reasons. There's more people participating in practice, so there's just more chances for injury. Oftentimes practices are longer than games, so our exposure is longer. So yes, we definitely need to be looking at practices, and that they always have the sensors on during practice. So we can look at we use this term to it's an all-encompassing term called workload. So we can look at their workload leading up to games and how their workload trends over weeks and within a week and compared to their teammates and for themselves. And so I'm sure a lot of people are familiar with tapering. In sports, we tend to have season-long tapers. We also have weekly tapers, and the taper depends on what part of the season you're in. So we can look at those trends. It's also really important that we not only look at the team practices, but many athletes will do individual work. Oftentimes, that individual work is one-on-one, and so it can be more intense, as in they're getting more motion within a shorter amount of time. That intensity can lead us to believe that certain types of tendon injuries might be more probable or coming up. And so making sure that we're monitoring them in those individual sessions also is really important. And then putting that whole picture together. When we talk about college athletes too, we also have to think about their, and this is any athlete, but I think about college athletes the most, I suppose, is where we are in the academic year, what's going on outside of sport that could be adding stress that could also lead to injury. We know that fatigue, which when people are stressed or anxious, some people tend to get less sleep. And how does that fatigue play into injuries? And I will say the injuries that we're probably the best at mitigating with this technology are overuse injuries. I don't think we'll get to the point where I can tell you 4 days ahead that someone's probably going to break their finger in the next game. There are just injuries that happen because sports happen and injuries. When I think with this technology, I'm really thinking about a lot of lower extremity or low back pain type injuries, the tendon injuries, the tendinitises, the Achilles tendinitises, stress fractures, those type of injuries that we can maybe modify things like workload or add in different recovery modalities or rehab therapies to help them mitigate that if we're seeing trends in their data.
Yeah, this is a great segue back to what I was asking about the heart rate. It's actually not the heart rate itself, it's heart rate variability.
Yes.
The heart rate variability is very predictive of
heart rate variability is phenomenal. It's very hard to get during a game.
Right. But before the games.
Before the games we can. So there, for a while, teams were using something called Omega Wave to get HRV. It tends to be a little obtrusive and it's hard to get people in that relaxed state. Now we're seeing more and more teams use the Oura Ring. And so the Oura Ring athletes can wear all the time or just at night, and their heart rate variability is very good. And so I'm really excited to see what we can do with that and look at that. And that's something we're exploring here at UVA.
Yeah, just another little side note on what we're talking about.
Yeah.
For those who are listening, this heart rate variability is actually a good thing for just a normal person, not an elite athlete, to use. And it's surprising. I know people are always surprised when we talk about this to know that heart rate variability is good when it's high. That's a healthy indicator. Low variability is bad. So it's like a lot of things in, frankly, physiology, that the greater the variability, the better it is. It's a good thing. What about you, Steve? Have you used computer vision around these training kinds of things, or has it all been on the games themselves?
No, I think training is particularly something that computer vision is most frequently used at the current stage. Because like what Natalie said, computer vision is particularly good at detecting those overuse injuries and things like that. And those unfortunate accidents that happens in the field. I mean, those are something that we cannot really predict. But what we can predict are the things that are like, there's a repetitive pattern of, shoulder exposed to some high amount of or abnormal amount of deceleration or, those kind of things is what we can capture and measure. So a lot of teams and, organizations actually use computer vision to monitor their practice sessions so that they can accumulate the data of what kind of movement patterns are repeatedly, emerge during the practice for each different player is kind of the use case scenario. People also use computer vision system for sort of a screening task. So like, what is your range of motion? Like how far you can bend your shoulder, your elbow, those kind of things. And then with the modern, computer vision based motion capture systems, you can kind of automate that process so that it becomes easier to collect those data, meaning that you can more precisely monitor the people with a more frequent measurement. So I would say those are the use cases of computer vision in training.
Yeah, that's great. I want to go back to to your Minority Report example and this idea of prediction, particularly around tactics and I'll say in the game. But I'd say I'm trying to think now, it must have been at least 4 years ago, I had an undergraduate who went to work for a summer for a professional baseball team. And in that, he worked he built a system that was pretty cool. It basically gave them a way to predict how to set up their defense, their infield defense, so where the second baseman and the shortstop position themselves based upon the current pitcher and the current batter. So as soon as the batter came up, they would adjust. And it was looking just at the data and the way in which this particular pitcher and this particular batter were likely to interact so that the batter would hit in a certain direction. And the infield defense was then adjusted accordingly. And it turned out that worked real well for that team. But I'd like, I guess, if that's 4 years ago, now the state of the art is obviously much better. Can you talk a little bit about the tactical side of things? So in other words, let's just play out the American football analogy. You're you're down. You've got let's say you're third down and 4 or something, and you're facing a certain team. Can you see a point where we can run a predictive set of models against that situation and give an outcome that's relatively accurate based upon the current setup of the people on the field?
I think for that, Natalie's a bad person to answer.
Yeah, I think we'll get there, especially if we have historical data on teams and how we know they typically react to certain situations on the field. And I wouldn't be surprised if this is already happening on individual teams. We don't often get to know what individual teams are doing. It's proprietary information. They don't always like to share it with the researchers. I also this also brings up some conversations I've had with another professor here, Alex Gates, in network analysis. And when you have certain groups of players on the field, do they interact differently and adapt to situations differently than other groupings of players? And I think that is really interesting, because I think one of the things we've kind of danced around in this conversation a bit is that sports has, a huge human psychology aspect, and that we can have all the historical data and all the models we want, but humans are humans and they make decisions based on in the moment, feelings, and that might be who are their teammates on the field and who do they feel comfortable with, who do they kind of have this, second sense about, knowing that they're going to catch this ball even if it's not the play we talked about. And I think that's some really interesting work to get into with, Alex and his network analysis type thing in sports. I was also thinking, I was watching the basketball game last night, and I think UVA held NC Central in the first half to 29% shooting or something. It was somewhere around there. And I was thinking, I was like, wow, this would be really cool computer vision to know how much of that, because the announcers say UVA held, as if UVA blocked every single one of those shots. How much of that was, UVA's defensive strategies versus how much of it was more of a unforced error type issue? And how does that look on the court when you put it into a computer vision world? And I think those are some really cool questions that we'll be able to start answering that I think could really change how coaches, think about the sports and how they set up strategies and who they put on the court and what combinations of players they put on the court to achieve certain outcomes.
Yeah. Well, the psychology, though, is detectable, isn't it? Or latent aspects are detectable by computer vision, aren't they, Steve? Or are they not?
There are certainly attempts to detect psychology using things like facial recognition and things like that. But I guess, psychology is something that is more difficult for, computers to process, because those are all very subjective, And then in terms of training an algorithm, how human psychology works, all these data points are very subjective. Meaning that, it's very hard to find a sort of a deterministic rules between if somebody's face looks like this means anger, or if somebody's face looks like this means depression or something like that. It's very hard to define that. Linkage is kind of the challenge. So psychology is probably something that data science models are not particularly good at the current stage. But who knows? There are a lot of research going on in terms of analyzing the brain waves of people, and then try to find some quantitative evidence of human psychology, and then try to incorporate that into decision-making process in sports science.
Yeah. And then just add a helmet to the computer trying to read a facial recognition. That's a whole other challenge.
Right,
when half their face is obstructed by a mask.
Yeah, but of course in basketball you've got their full face.
Yeah.
And so in your example that you were just giving, you can actually detect, I would think, certain characteristics. But
I think so. Yeah. It's funny when Steve was talking about pose estimation in the beginning. One of the first talks I went to about pose estimation was about basketball, and they were talking about how do they track the same player throughout the game. And the first one was, the number is the most obvious. Like it's usually you can at least see part of it and the computer can figure out, oh, that's 21. The next thing that they said worked for their model was the nose features. And how, some people have such a different shaped nose, and how the computer was like, oh, I can identify that person's nose to identify them if they couldn't see the number. And so it's very close to a facial recognition between athletes.
And the next would be the ear. No,
maybe. I don't know. Probably. Yeah. Probably better than the arm. I'm sure all of our arms look alike to the computers. Yeah. That's going to be some interesting avenues of human psychology. There's a whole reason there's a whole field dedicated to trying to understand human emotion and the mind. Yeah. And it's we talk about it all the time in sports.
Well, can you talk a little bit about what you think are the current really fascinating challenges that we have right now?
From the research lens, I sometimes wear both hats of working with individual teams and also trying to think about these larger research questions. First, it's really getting all this data together. And I think a lot about how do we go through this entire data science pipeline. And we'll use the U-shaped pipeline. We're going, from sport back to the sport. And it's, we're taking all of, how do we collect that data so it comes into our system really nicely? How do we then put all of those data points together? Because oftentimes, and this might be not the right answer for this podcast, is sometimes our best answers come from a really good query. Sometimes the answers we need the most. If we have that data really well designed and laid out, we can run a quick query and get most answers that we need quickly. But that doesn't happen if all of your data isn't together and working seamlessly. And then, there's also the challenge of how do you get video into those, we call them databases, is another challenge. And then how do we then stream that back out to another human readable side for coaches? Because there are stakeholders, coaches, athletes, fans, and they're not necessarily going to understand the sensor data or the camera data that we brought in or the medical data that we brought in. And so I really think more of this design problem of putting all our data in, making it work really well together and at scale so we can continually add that data in quickly, and then being able to seamlessly put it out into reports, dashboards, fan engagement platforms is probably the thing I think about the most. And then that's on a kind of an individual sports side, but that leads to the larger research side of I've been trying to get more data from other schools together. And the biggest issue is that no one's data is stored the same. We all don't collect our data the same. So how do we create processes to still bring all of that data together? And we're definitely working towards it. People don't like to share their sports data. I always try to tell people that, especially in college sports where we have so much turnover, if I'm asking for data from 2 years ago, there's nothing I'm going to be able to predict competition-wise on your team this coming year. And we're also looking at it from a health perspective, which usually gets people more engaged. But this is something that we've been talking about and working on at UVA for years, and we're still just barely inching towards getting more of this data together to really solve the problem of how do we keep our college athletes healthy. Because many of these athletes don't go on to play professional. We just want them to be healthy, active humans in our population. And so how do we keep them that way in college sports?
Right.
Yeah.
Okay, that's great.
Yeah, just to echo what Natalie just said, I think we have all this, nowadays, this cool technologies to produce all sorts of interesting data. But when it comes to collecting them and then making use of them wisely, I think we're still kind of behind, especially in terms of collecting and integrating all this data. Different teams use different data collection methods. Different teams use different sensors and so on and so forth. So how to kind of collect those data and then integrate them together for some productive use is, I think, a remaining challenge. Another thing I want to add is machine learning models and data science algorithms are getting more and more accurate, but on the flip side, they're becoming, more and more sophisticated to analyze. So in terms of analyzing the decision process of those data science models, it's becoming, more and more challenging. Meaning that, let's say there's a machine learning model that can predict, the probability of somebody getting injured, but then the question is why? What are the things that machine learning models saw in the player's data that made it to predict certain probability of injury? We don't have a lot of technology to understand and visualize and explain what's happening inside of machine learning models. So I think that's another very important challenge, because we need that kind of interpretation to communicate with people, communicate with not necessarily data science. We need to communicate that the machine learning prediction to coaches, players, and other stakeholders. Right? Mm-hmm. We need to clearly communicate that, and then we need to have some human interpretable justification of why that machine learning model has made that prediction, that sort of thing. So I think that's another big challenge that we need to address.
Yeah. Steve hits on something very important there, especially in the sports medicine side. There's still a lot of just experimental causal things that we need to solve. And one of them, so the sensors I was talking about that they wear between their shoulder blades, that's full body load or full body accelerometry. We don't exactly know what that means for a knee tendon. If you get 500 workload units, does that change any of the structure of your knee tendon over time? And those aren't these big data problems. That's controlling player load and measuring tendon changes over time. But those are very important pieces to this larger puzzle that can help us bring some interpretability to the machine learning. That also hits on a point that we made earlier, that the more human interpretability we can put in those models, the more protected the athletes are from decisions being made without a lot of guidance from humans and just solely relying on computers to make those decisions for athletes. So let's remember, in professional sports, this is their livelihood. In college sports, this is the potential to be their livelihood. And now with NIL, it is some of their livelihoods, really. And so we can't make decisions just purely based on solely what a computer is telling us without some human interpretability for them. And I think all of our athletes, coaches, deserve at least that much from us.
Yeah, that's great. So I guess to conclude, can you guys think of applications outside of sports that some of the techniques you've been working on in sports analytics can be used for?
Yes. There's, human motion. Every human moves in some capacity. And so I think that in itself is interesting. Staying still in kind of the sports medicine or medicine realm, when we look at, rehab throughout the lifespan, having some kind of sensor or computer vision to look at those human motions is incredible, especially when we think about remote therapy. Not everyone has access to high quality physical therapists in their hometowns. And so how can we use this technology to, bring high quality rehab and physical activity to people who don't have direct access?
No, I can think of a lot of applications outside of sports. I think what Natalie just said, rehabilitation and precision medicine, I think is going to be one particular direction where this can go. What I can tell from my own experience, I know that, for example, U.S. Marine Corps is using this kind of sports analytics methodologies to train their soldiers better and things like that. that. I also know that manufacturing industry is nowadays is paying a lot of attention to those repetitive use injuries of the manufacturing workers. So like you lift a heavy object and then you repeat that motion, over and over again, or you lift your shoulder in a certain way to reach to a part on a shelf, and things like that. And then there are like companies in the industry who are developing computer vision and sensor technologies to monitor and detect all this repetitive use of motions in manufacturing. I also have a collaborator in the pediatrics department at UVA who's using computer vision to analyze the movement of infants. And then there's an interesting tendency where infants with the risk of cerebral palsy tend to have very monotonic, repetitive movement, whereas normal babies tend to just move in a various different ways. So similar technology that is being used in the sports industry could also be applied to automate the process of predicting the future risk of cerebral palsy and that sort of thing. So I can see, a lot of applications like that outside of sports world could benefit from this, new technology.
Yeah, I would second that. From what I've seen, the various techniques that have been used for elite athletes to measure performance has direct applicability for normal people to improve their physical fitness and exercise modes. So I think this is all good.
And all of us have a sensor on us called our cell phone. That, it actually does pick up a lot of what we do every day. And a lot of people wear, smartwatches or have their own Oura rings that give great HRV and can tell us a lot about how we ourselves are doing as humans.
Yeah, I recently came across this app which analyzed my golf swing, and it tells me, why my swing sucks. So I think, yes, I can see this, all this high technology kind of becoming more, democratized, and then, a broader group of people can, start to benefit from those technologies, so which is pretty exciting to me as well.
Right. So when we do sports, we get full benefit out of it. That's the goal. Yeah.
Which is our golf game.
All right. Well, thank you very much. This has been wonderful. I've enjoyed talking to both of you.
Thank you.
Thank
it was fun.
Thanks for checking out this week's episode, and thanks for listening to the first season of UVA Data Points. We've really enjoyed making this podcast, and none of it would happen without listeners like you. We'll be back with a bonus episode in mid-December, which features a live discussion at our recent Datapalooza event. While this current episode concludes our 4-part series on the 4+1 model of data science, we'll continue to release monthly episodes while we work on the second season of UVA Data Points. The subjects of these episodes will vary, but still remain in the domain of data science. If there are any topics you're interested in hearing about, feel free to contact us at uvadatapoints@virginia.edu. Thanks again for coming on this journey with us. We'll see you next time.